and welcome to our cosmology segment. It was originally streamed live to Twitch at twitch.tv/smAsho. Some of our cosmology segments are integrated into our daily space weather videos. Others are not. This one is not. So we're starting out with a diagram of the solar system here. We're going to give you a little forecast of where things will be in a week. And there's where things will be in a week. We'll be talking about Lagrange points, a gamma ray source, and more in today's cosmology segment. So let's get to it now that we've shown you the 1 week forecast of where things will be in the solar system as Mercury swings around to pass Mars. So we regularly talk about Lagrangian points, and we do have a coronal mass ejection going on. Now we've made this image here, we've embellished the image to include the stereo A little tab there. This is actually a NASA image. We just added stereo A to it, depicting where Lagrange point 5 and Lagrange point 1 are located. They're gravitational equilibrium points where the gravitational pull of the sun and the Earth reach equilibrium, and the spacecraft is able to orbit the sun like the Earth. L2 also does the same thing. L1 does the same thing, and L3. And let's not forget L4, where stereo B is located. And looking at the view from L5, that's stereo A over here, located at Lagrangian point 5. On the right is the SOHO-LASCO C3. And again, we are expecting a coronal mass ejection. Actually, we're expecting two of them. We're expecting one over here and one over here. And they can affect each other. I won't get into the physics of that. Just to say, don't be surprised to see us make another video later today when a coronal mass ejection occurs. So there's an article in SciTech Daily today about Lagrangian points. Why? Because of a mission to study Trojan asteroids. Now, Trojan asteroids are ones in Jupiter's orbit, and the mission is called the Lucy mission. So there's a little article here in SciTech Daily about Lagrangian points because of that mission being launched soon. Not exactly sure when it's launched, but perhaps check that one out. And also check this one out because it's another article about asteroids. So asteroids have ways that they evolve as they fly through space. There are forces exerted on them besides just their own inertial kinetic energy. We also get expansion and contraction, which is caused by heating up and cooling. And of course, the surface of asteroids is irregular. As they rotate and they tumble through space, sunlight heats up the sun-facing side, which causes some outgassing, and that can push the asteroids through a rocket-like effect. As they lose mass and blast it out into space, they are pushed in the opposite direction of the sunlight. Also, the expansion and contraction causes cracking on their surface and so on. And so there's more at play besides just the inertia of those asteroids. There's also electrical and magnetic effects associated with charge differential when plasma arrives and so on. Keep in mind, asteroids don't really have a magnetosphere like the Earth, and so charged particles behave differently when they show up. They largely collide with the asteroid. So here's an article on SciTech Daily about this as well, showing two SciTech Daily articles in a row here on the cosmology segment, how the sun affects asteroids. And so the Lucy mission, we'll be checking that out. And I'm just letting the article scroll here. If you'd like to read it, feel free to pause the video. Don't worry. We'll be here when you return. Even though we streamed it live originally, this was uploaded to YouTube. So video on demand, twitch.tv/smAsho is where this video originally aired. That's SciTech Daily. Let's talk about the locations of stars above my head. Yeah, so I've set up in-the-sky.org's star chart. We've drawn in the galactic plane and the ecliptic. At least I thought we did. I can see it. It's getting light. And we've got multiple objects here showing up. Mercury and Mars rising ahead of the sun at the moment here over Lehigh Valley, Pennsylvania, as it just gets light here. Let's continue on with our cosmology segment. The astronomy picture of the day is from today, How about that? November 8th, 2021. A great image here of a filament, a massive prominence here. Let's actually shrink that down so we can see the whole thing. Great high-res imagery there of a solar prominence. And indeed, coronal mass ejection. There's no way all that ejecta will splash back down onto the chromosphere area. Spectacular. And I'll scroll down so you can see the caption. Again, feel free to pause the video on this. That was taken from a small telescope in France. Today's random and quote number is 242, which coincides with a gamma ray source. So this gamma ray source, you can find it at the Neil Gehrels Swift-Bat X-ray Observatory if you want to. Again, it's number 242 of 1,051 objects. Gamma ray source 2CG 235-01. Now, when we look at it in its hard X-ray outputs, you can see it could be an eclipsing binary here. As we can see the way it's got this clear cyclicity. So maybe there's a eclipsing binary scenario going on there. You can see it's much brighter and then much dimmer very regularly there over the past 30 days at least. Ultimately, we don't know what it is, other than that it's a source of gamma rays. So gamma rays, looking at it in optical frequencies, does not yield much. The Pan-STARRS is quite a high-resolution survey, and when we zoom into that point, it's just a dark part of space. Let's take a look at it in some other wavelengths here. I'm just going to click on some random wavelengths here, look at it in radio. We'll zoom out a little bit. It's a radio-hot portion of the galaxy. It's a fairly busy portion of the galaxy in general. If we look at it on the 2 mass, it's going to show us a heap and helping of nothing. Just bear with me a minute. There's the color imagery from the 2 mass, the infrared thermal emission spectra survey. And yeah, it's a pretty dark portion of space there, folks. A pretty dark portion of space indeed. So when we go up to higher frequencies here, like X-rays, we do expect to find something. How about the Swift-Bat 70-month survey? Again, not showing up very much besides gamma ray emissions there. And of course, we did show that it does emit certainly hard X-rays regularly. 2CG 235-01. Now, this was discovered back in the 1980s, by the way. Let me just see if I can get some X-ray data here on this. It does actually show up in some bands, believe it or not. Just bear with me. Is that a bright spot? So you can see how odd this is. And if you check this out on the CDS portal, you can find all kinds of links to it, all kinds of studies done on this object. Going all the way back to 1981, it looks like it was discovered in 1981. And you can see it's only apparently showing up in very limited portions of the electromagnetic spectrum here on the photometric points. That's today's object. Gamma ray source 2CG 235-01, number 242 on the Neil Gehrels Swift-Bat X-ray Observatory. Thanks for tuning into our cosmology segment. Congratulations on realizing the channel exists. Don't forget to check the other cosmology segments on our playlists, and we'll see you soon.